In this video we are going to learn how to use this amazing ZK-5AD motor driver module based on TA6586 chip. We are going to control two DC motor with start, stop, speed control, and I'm going to show you the wiring. So you can control 3.3 volts motor, 5 volts. The most important part is the voltage drop. Last line is connected to ground. 3.3 volts is not used, so 3 ampere is heating up 69 degrees Celsius. This is without using map. We say when the speed is input is connected to high current power source. Let's see how much voltage drop we are getting. Hi, welcome to an Arduino step-by-step course by Robojax. The important part is the voltage drop. With comparing to L298N, this has about 2 volts voltage drop at 2 ampere, but this one at 4 ampere, one chip at 4 ampere will drop only 400 millivolts, and that is great advantage because the lower the voltage drop, the lower the heat dissipation and efficiency will increase. And with this spec, this is a game changer. So this is the module, and we have main input, positive and negative, and from one chip we have these two terminals for the output, and for the other chip we have another terminal. So we can connect one DC motor here, one DC motor in here. These are a little confusing, but and we have ground, and then we have a 3.3 volts regulator, this regulator in here, and that is outputting. For this chip we have two input, D0, D1, and these two inputs are for this chip. So it's very simple. We have, if you want to connect it to your device, or let's say Arduino or another device, just connect ground and 4 pins. 2 pins for this and 2 pins for this chip. These are just extra capacitors, and then here we have a 3.3 volts regulator which outputs here 3.3 volts. So this is a 3.3 volts. We have ground. Pin is not connected. I do not find any connection. The pins also have been labeled here. Motor 2, these 2 pins are for motor 2, and these 2 pins are for motor 1, and input have been also labeled as positive and negative at this point. We have one small hole here to attach it to something via this hole. Length is 38.2 millimeters. Width is 27.4 millimeters. The height is 14.6 millimeters. And here's a data sheet for the TA6586 motor controller. This is from RZ Semiconductor, and standby current when the motor is not running is less than 2 microampere, and the operating voltage for the motor, you can control the motor from 3 to 14 volts, so even 3.3 volts will work. Built-in brake function, thermal shutdown. When it's hot it will shut down, and here it has overcurrent and short circuit protection. They call it backward input and forward input, forward output, backward output. So this is the truth table, and as you can see, for the output, either high and low or low and high will rotate the motor, but if both output is low, then input should be high, and that is a brake. Otherwise it's just open. The voltage, rated voltage maximum is 15 volts, and current is 9 ampere. This is a little strange, and we are going to test it. Minus 25 to 85 degrees Celsius. Here is the application circuit. This is a chip, and we have one pin for VCC, other pin for the ground. We have 2 pins for output forward and output reverse, 2 pins. So the motor is connected to the 2 pins 5 and 6, and the other side of the motor will be connected to 7 and 8, and this is for the purpose of heat dissipation, so it can act as a heat sink, releasing heat from inside the chip. So we have input forward and input reverse. And here high output voltage at 6 volts with 3 ampere we get 5.7, and from 6 we get 5.7, so 300 millivolts is dropped. That's a typical. We're going to test that. And these are the high and low input voltage. 2.2 to 3.5 volt is considered as high for the input, and 0.5 is considered low. Continuous current, it says 5 ampere, and maximum is 7 ampere. So for 5 ampere they have conditioned that the 2 output pins, they must have auxiliary heating copper for heat dissipation. 2 pin is connected, so more heat is being dissipated from the chip. When you compare it to L298N, here is a data sheet for L298N, this chip, and as you can see, repetitive current is 2.5 ampere, and peak can be up to 3 ampere. So and here is the wiring diagram. The battery is connected, the positive to the last terminal, the negative to the second one. For the 2 motors, you will connect 2 wires for the 1 motor at this terminal, and for the other one to the other terminal. The polarity will change when you connect the positive from this wire to this or to this wire, when you switch them. For the ground, this line, the last line is connected to ground. 3.3 volts is not used in this case. We are not powering this up. This is the output, but these are the most important one. The last pin is not connected. From this we are connecting it to pin 3, 5, 6 and 9. These wires that have the tilde, these are pulse width modulation pins. These 2 will be connected to this chip which controls this motor, and these 2 are the input for this chip which controls this motor. And here is the actual wiring. This motor is connected to this pin, to this terminal. This motor is connected to these terminals. The polarity doesn't matter. You will figure it out which one works for you. This last wire is connected to ground at this point, and these 4 wires are connected in order. You can see them in order. That's orange. Orange is connected to pin 3, yellow is connected to pin 5, green is connected to pin 6, and blue is connected to pin 9. For the power, if I'm connecting 5 volts, so it is connected directly to this point, powering up from Arduino, and I'm connecting this to my external 5 volts power. So the 5 volts come here, and from here it powers up my motor. We are defining D0, D1, D2, D3 in this order: pin 9, 6, 5 and 3. These are the pins that you will see beside them. This character, this is referring to pulse width modulation, and then we are defining clockwise as true and counterclockwise as false. Do not change these. This line is about debugging to display the information on the serial monitor. Debug, if you want to see the debugging information like this, when the motor runs or stops and all this, then set this to true, otherwise just say false. Finding inside the setup, we are defining the serial monitor with 9600 baud. This is the number that when you open the serial monitor, this serial monitor with opens, and this number must match here with 9600 baud at this corner, otherwise you will not be able to read the text. This is just printing the text, and we are using the pen mode. These pens and D0, D1, D2 and D3, we are defining them as output, and this portion of the code runs only once. Then inside the loop we have this function called M2 and M1. We are passing the direction clockwise, and we say at 80%. This is a percent from 0 to 100. Line sets motor 2 at clockwise 80% and motor 1 clockwise at 100%, keeps it for 3 seconds and then break for motor 2. This 2 means motor 2 break. This is for break. I will explain this function and M1. And then delay means when you apply brake, wait for 1 second. For real application, if you are building a car or something, you don't need this delay. You will run it continuously with different functions. M2 again, CC, this is counterclockwise at 60% for 3 seconds, then apply brake to 1 and then brake to number 2 again and wait for 3 seconds. This is just a loop for test. I is incrementing with this number. I have separate video about for loop, watch that. So I is increasing 0, 1, 2, 3 up to 100, and when I changes, we go to motor 1 in counterclockwise direction, and whatever is the value of I, we send this to this function. So the motor 1 will run in counterclockwise at the speed that I is, and then gives it 100 milliseconds. So this goes from 0 to 100%, and after that wait for 2 seconds at 100%, and then applies brake, wait for 3 seconds, and the loop is ended. It comes back, does all these things all over again. Now say M1, motor 1, we pass the direction which is CW or CCW, and we bring also the speed. So we have direction and speed, and here we get that speed using map. We say when the speed is from 0 to 100, convert it to 0 to 255, which is used by Arduino, and the result of this calculation is stored in a variable called PWM or password modulation. And then we check the direction. If direction is equal CW, then we set D0 to pulse modulation and D1 to low. So this motor rotates in clockwise. Otherwise, we just change D0 and D1. You see this, it was D0 pulse modulation, now else D1 is pulse modulation and D0 is low. Now, and then we use debug. 1 mean motor 1, that direction, the speed, and then do not break. So this is just printing the text for us. And the same thing, exact same thing is for motor 2. All the function except the pens are here different, and it prints the value for us. And for the brake, this is a motor number. If it is motor 1, then we apply to D1 and D0 the value of high, and if it is motor 2, we apply value of high to this D2 and 3. So it will stop the motor, and also it prints the text. Debug print is this function here, which prints the motor 1, motor 2, and all these values. This is very simple text. It's not important. If you found this tutorial helpful, please thumb up, and also click on the subscribe on the right side in the lower corner. I really appreciate it. If you're connecting 5 volts to Arduino and your motor is 5 volts, then it will be very easy. This 2 wires that are from here connected directly to 5 volts and ground. like that. So this point is connected directly to 5 volts, and connect these 2 pins here. The last one, this is positive, this is negative. So I'm connecting a wire here, a pair of wires. Now I can power it up from my external power, which is 5 volts. So this is 5 volts, and I'm connecting it. And here is a demonstration. This is running, this motor is not running. Now both now this will run slowly, speed up. Now I've connected this to the load. Input is connected to high current power source, 12 volts, and I've connected these 2 pins like that. So this motor is on, and this pin is positive, this is negative. So I've connected it to ground and 3.3 volts. Now this is just running at 100% duty cycle, so I can test the amount of current. Now this is my electronic load. Now I've connected the 2 terminals. These 2 terminals have been connected in here, and we will read the voltage and the current. Let's go 1 ampere. Now 1 ampere is set, I'm turning it on. Now 1 ampere is being supplied by this chip, so I will increase the current. Now 2 ampere. Let's go 3 amp. So 3 ampere is being supplied by the chip. Very cool. 4 ampere. This is without heatsink. This is amazing. 4 ampere without heatsink. And here is a thermal image. I'm using this thermal camera. The link for this camera is below the video in the description, and let's see it. Now it shows 132 degrees Fahrenheit, 60 degrees Celsius, and I've left it now with 4 ampere for over 10 minutes, I believe. So 59 degrees Celsius. Let's change it to 5 ampere and see what happens. Now the current is 5 ampere. I'm sure it will heat up, but we have thermal shutdown, so I'm not worried about it. Let's see. As you can see, it's heating up. 69 degrees Celsius, 70, 72 degrees, 73, 74. By the way, this is 100% duty cycle. So if the motor runs at full power, that's where it happens. So 77 degrees. Now let's see, I'm adding these heat sinks. These have some stickers with adhesive. Let's just apply one of them and see how much it can handle. The link for this will be below the video in the description. Now I'm attaching this to the chip, so it has been attached now. As simple as that. Now let's turn it on with 5 ampere with the heatsink, and let's see how long this can hold it. Three, 73, 74, it's heating up. 75. Let's go 6 ampere and 7 amp. Now I've turned it on with 7 ampere. Let's see how fast this heats up. So as you can see, thermal shutdown happened. It's turning on and turning off because it heat up. The heatsink shows 46 degrees. Now let's see how much voltage drop we are getting when we draw current. So first, without the load, let's read the voltage with the same meter. Let's measure the output. 12.09. It's exactly the same, but this is accurate. So this is reading it incorrectly. So we have to compensate for that. This is almost 12.1. This is 12.15. So 50 millivolts. There is a 50 millivolts. This is reading less. Keep that in mind. And let's add 3 ampere. So 3 ampere is set. Now this is now 12.7, 12.07. With the 3 amp we have 12.06, and then 0.6 is the difference, plus 0.06. That's actually the voltage at the moment here, 12.12. and output is 11.8 and 320 millivolts drop. Now let's increase the current to 4 amp. I'm making it now 4 ampere. Now 4 ampere is being drawn. Now this is 12.03 plus 0.06. Now the voltage is 12.09 at the input, and the output is 11.64 minus 11.64. Let's put the 65. 440. So at 4 ampere, we have 440 millivolts drop. Let's go 5 ampere. So this is now 12.01 plus 0.06. Now this is 12.07 minus 11.47. So 600 millivolts drop at 5 ampere. Now here is my conclusion. This can handle 3 to 4 ampere continuously. This is amazing with this small size without a heatsink. I said 3 to 4 ampere because my room temperature is cooler in some area where the environment is very hot, so you cannot go above 3 without a heatsink. But if your room is cool, then that will be also fine, and you can have it up to 4 ampere continuously. But if you put a heatsink, you can go 5 ampere, even 6 ampere if you have larger heatsink. I had larger heatsink, but they do not fit. So perhaps you can find, this is 10 millimeter by 10 millimeter. If you find heatsink with a longer length, you might be able to get higher current for continuous time because it has been rated. The typical current is 5 ampere and maximum is 7. So typical current with heat dissipation is 5 ampere, and that is true. In this video, we are going to learn how to control 4 DC motors that you might need to use for robot car or any other application using L293D motor shield with Arduino. This is Arduino Uno motor shield. I'm going to demonstrate and show you how to use it with Arduino Uno and also Arduino Mega. In both cases,